let's think about how we can visualize numbers using Minecraft. Let's start easy with just the number 1. Well, we can't really do much with 1. What about a number like 4? Well, I could make a number like 4 using 4 blocks, and what's neat about the number 4 is that I can make it into a square, right? That's 2 by 2. And what would the next number be that I could make into a square? Well, that next number would be 9, because I can do 3 this way, 3 this way, and then fill in the rest here. And then when I count how many blocks I have here, right, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And I can keep doing that. I can keep finding, we call these numbers actually perfect squares because of the fact that they make squares like this. So the next perfect square is 16, which I get by doing a 4 by 4 square like this. I'm really good at filling in squares on Minecraft. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now, if I keep going, this is going to get ridiculous. So this is what I think is a relatively obvious way of looking at numbers that are perfect squares. But what about all these numbers that are not perfect squares? Then what do we do with those numbers? So let's think about a number that's not a perfect square, like, let's see, 1, 2, 3, 4, 1, 2, 3, 4. Like, let's think about 8. And what are the different ways that we can make 8? Well, these are really similar colors of blue. So let me pick a different one. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. So one way to represent 8 is just to make a line of 8 squares, but then we've got this lighter blue here which shows that there's another way to represent 8, which would be to do 2 by 4. But we also could, I suppose, represent it this way, where we've got 4 coming down into a cross. I would argue that the light blue and purple squares there, though, are the same. Well, there's not much more that we can do with 8, or at least it doesn't seem like it right now. Let's think of a different number. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, the number 12. We could do 1 block, 12 long, or, right? Or we could think, well, what if I want to basically split that in half and then do 2, and then how far across would that be to make 12? 1, 2, 3, 4, 5, 6. Well, if you're thinking about your multiplication tables, this should make sense. 2 times 6 is 12. So what else would work? Well, we could do 3 down and 4 across. Oh, 1 too many. 3 down and 4 across, and that's going to make 12 because 3 times 4 is 12. So this isn't supposed to necessarily be teaching you anything new. It's just a way of visualizing numbers, which may help you think about the factors that make them up in kind of a cool new way. So we also, of course, could think of these the other direction, that instead of 3 by 4, we could think 4 by 3, we could think 6 by 2, and 12 by 1. What else could we do with this then? I've got these 3 situations and then there are kind of reverses, but what if instead I do something a little different? 1, 2, 3, 4, 5, 6, but I've got 6 more blocks. What if I put them on top? Ooh. So now I've got a 3-dimensional figure instead of a kind of a 2-dimensional figure. Yes, actually all of these were 3-dimensional in some ways, but I've got layers now, right? That it's 2 by 2 by 3, which 2 times 2 times 3 is 12. So this kind of adds a level of complexity on what we could do as far as how to represent numbers visually in this way. Let me get an open spot here, and I'm going to pick a new number. And I want you to think about, before I do, I want you to think about how would you arrange this number. So what number should I pick here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So the bigger the number, the more interesting it might be. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, that is 20. So how can we split 20 up? How else could we arrange it? Well, 20 is divisible by 2. So we could think 2 times 10 and that would give us something that would work. 2 by 10 would be 20 blocks. What else works? Now this actually is an interesting thing we could do to visualize why 3 maybe doesn't divide in. And we could do this with the original green or with this blue. In order for 3 to go in here, if I group these blocks into sets of 3, that went really fast. If I group these blocks into groups of 3, I can't have any spaces left over. So 3 doesn't divide in. Now we've got a 4 by, 5 situation, except I've one too many. 4 times 5 is 20. And so we've actually thought of all the factors now, because to multiply to get 20, we could do 1 times 20 or 20 times 1. We could do 2 times 10 or 10 times 2. And we can do 4 times 5 or 5 times 4. Well, what about our other situation that we just looked at, where we could turn these into things that are 3-dimensional? You know, how could we go about doing that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we can build on top of it. So we've got 10 blocks on the bottom, 10 blocks on the top for a total of 20. So this is 2 by 2 by 5. And really, because that's the prime factors of 20 is 2, 2, and 5, all we can really do is make different versions of the same block. It won't actually be different dimensions. It just might be, it'll be a different perspective. So I can make it tall instead of long, like so. But that's really the same figure, just on a different side. So that's 20. Let's look at another number. Maybe. The problem is, the bigger the number, or the more interesting the number, the harder or less likely it is that we'd want to actually make those blocks. So let's look at 16, which might be interesting. So I'm gonna actually change colors here to make it easier to count. So 4, 8, 12, 16. Okay, so 16 is 1 times 16. But 16 is divisible by 2, because we can group these into 2 and have it divide evenly. So 2 times what gives us 16. Don't read too much into when I decided to change the colors here. I've got 2 by 8. 2 times 8 is 16. What else could I do? I can do 4 is divisible. 3 is not divisible, but 4 is divisible. And that's actually a perfect square situation, because if I do 4 by 4, I get a square. So those are kind of the 3 sets of factors we have: 1 times 16, 2 times 8, 4 by 4. But then what sort of 3-dimensional situations could we make? How can we group up these numbers together? So we actually could do this, where we could say I've got 1 by 4 by 4. Oh, don't mind me, guys. I'm just over here doing some math. So that's the way that we could do this. We can just make it go up instead of across. What about 2 by 4? And then I can stack the blue on top. So I kind of am actually visualizing breaking up those original 2 and stacking on top of each other. And then interestingly, or maybe not, this doesn't actually have any other 3-dimensional figures, like unique 3-dimensional figures. We can rotate them around and do a different perspective there, but they still end up being the same thing. Like I would end up with it being tall like this. That's a possibility. And part of the problem here is when you break 16 up into its factors, it's 2 times 2 times 2 times 2, which means we have 4 2s, and there's not really a good way to represent 4 dimensions in a 3-dimensional world. Thanks for watching. I hope you enjoyed this video where I mix Minecraft and math together. It's one of my favorite things to do. Please like the video if you liked it, subscribe if you're not subscribed already, and I'll see you hopefully in another video soon. Thanks!